And in this second tutorial, we will be able to graph exponential functions again, this time when a is not equal to 1, and still be able to state the domain and the range. I'd like to flip over to the last example that we had done because I wanted to actually talk about the range from the last tutorial. The domain and the range for a of x here did not change from what the normal domain and range is, but this one, the domain of course is still all reals. In fact, all of these are going to have a domain of all reals, but the range is different because we've been able to shift down 2 units. So the range is going to be from -2 to infinity. We're still not touching the value of -2. We're not touching that horizontal asymptote, but that is the lowest that we would start and go up to infinity. Now we're going to look at c of x and d of x. These each have a value of a. H and k for both of them are 0, so we're not looking at the shifts right now. We're just looking at the value of a. So I'd like to graph this first one. A this time is a 2. And you can see that clearly because there's a 2 being multiplied to my power. H and k, like I said, are 0, each of them, because we don't see anything up here with the x, and we don't see anything added or subtracted to our main function. So 0, 0 is where our star would be, but that's normally our starting point, so that's not a problem. I'm going to put my horizontal asymptote right through here. That's where our normal horizontal asymptote is anyway. So what we need to do now is graph our function, but we need to multiply all of our regular outputs by 2 because that's what a does. We're going to multiply by 2. I'm going to say multiply the outputs by 2. So our normal outputs, let me put them off to the side here. Our normal outputs for a base 3 would be 1, 3, 9, and I'm not going to put the 27 because again, rarely are we using the 27. So 1, 3, and 9. Maybe I'll put some of the cheat points as well. 1/3, 1/9, maybe even 1/27 if we really want to. Okay, so those are our basic points when the base is 3. What we need to do now is multiply each of these by 2. Each one of these outputs is going to multiply by 2 because that's what the value of a is. So now our outputs are actually 2, 6, and 18. If we want to do the cheat points, that would be 2/3 and 2/9 and 2/27. Okay, so there's still fractions that are getting tinier and tinier, but the important ones over here are 2, 6, and 18. So when we go to our 0, and maybe you put a little star in here, I don't know if you've already done that. That's our regular origin, so maybe you didn't. That's fine. Normally we'd be going 1 unit above the starting point, but this time because we're multiplying by 2, we're actually going 2 units above the starting point. When we input a 1, that would be like the first power of 3. We don't get to go up 1, 2, 3. We have to go up 2 times as much. So 1, 2, 3, 4, 5, 6. And when I go back to the starting point, when I go over 2 units to the right, that's like 3 squared. Normally I'd be going up 9, but this time I have to go twice as tall to 18. And I don't think that I'm going to be able to fit that. It'll be way up here somewhere. I'll just guess about right there. Over here in our cheat points, normally they'd be 1/3, 1/9, and 1/27. This time it's 2/3, 2/9, and 2/27. 2/3 is still something that's less than 1, so there we go. And then we'll graph, and I'm going to go all the way up to this estimation point right there. And there we go. So when we do have a value of a, watch out. Our points are not in our normal spots. And some people like to do this, maybe an open circle where it normally would be at the 1 and 1, 2, 3, an open circle normally, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. These are our normal values where they normally would be. And you can see that the red values are twice as tall as the, I don't know, the blue circles. So there we go. Domain and range are the same as they normally would be. And our final one. So now our value of a is -5. A is a -5. H and k are still 0. 0 and 0. So 0, 0, which is our normal starting point. I'll go ahead and put a little star. but our A is a -5, and I'd like to see what happens because of that. Let's put on our horizontal asymptote right through where our starting point is. So now let's take all of our values and see what their outputs are really going to be based on the new -5. I'm going to put them right here. I've got my 1, my 3, and my 9. That's what I normally have. I'm also going to put my 1/3 and my 1/9. When I multiply by this value of A, I'm going to put that right here, I'm multiplying by a -5 for each one of these. And the first thing you might realize is that the negative is going to flip our graph upside down. And that's usually what the value of A would do when it's negative. So our first output is not a 1 anymore, it's a -5. And then it's not a 3 anymore, it's -15. And it's not a 9 anymore, it's -45, which I don't even think I'm going to be able to do the -15, so forget about the -45. The cheat points change from 1/3 to -5/3, and that's important to note, and 1/9 to -5/9. So let's see what we have here. Now we don't go one above the star. We would go one below the star because A is negative. But because it's a negative and a 5, we actually go 1, 2, 3, 4, 5 units below the star. That's where our first output's going to be. 1 unit to the right, like the first power, now we're actually going to have to go down 15 units. And forget that, because -9 is right here. I'll go ahead and estimate that it's about right here, but we're already off the graph paper. So really, this is the only exact dot that I'm going to have. Now let's look at my cheat points. Normally, when I go to the left, I'm going up 1/3. But because of the negative, I go down 1/3. But because of the -5, I actually go down -5/3. Now this is a number that's bigger than -1 or smaller than -1, but it's past the first tick mark. It's down 3/3 and another 2/3. So watch out for that, because yes, it is one of the cheat points, but it has to be in the correct location. The next one is -5/9, and -5/9 is about like -1/2, so that's somewhere in here. And then you can just put in some more that are getting tinier and tinier, no problems there. But this one is an important one to know where it is, because it's -5/3. And whoops, I missed that point by a little bit. I'll make it a little bit bigger. And there we go. So we can see that the value of A will flip our graph upside down sometimes. And now it's important to talk about that range. The domain is the same, but if we're looking at the range this time the lowest that the graph goes is actually -infinity. And it goes as high up as our horizontal asymptote, though it's never going to touch it. And that's the value of 0, but I'll put a parenthesis because we don't get to touch that value. Thanks for watching this second tutorial when A is something other than 1. And I'll see you in our last tutorial and in class to practice these. Bye-bye.